Mohan lost the link. I'm trying to send him the link.
Okay. Whole structure is yes. Yes, so I'll
Good afternoon, everyone. So hope all of you are enjoying the spells and smells of monsoon so far. So I formally welcome all of you to the first Monsoon Par Charcha 2024. Recently, Director IITM has handed over the responsibility of monsoon discussion, which was previously known to everyone. He handed over the responsibility to Monsoon Mission Group in order to make it an inclusive activity, discussion activity among all MOS institutions. In this activity, IMD will present a scientist or representative of IMD will present the observational aspects of monsoon. Then IITM or NCMRWF will present the prediction and the verification of monsoon across all temporal and spatial scales, such as short range, extended range, long range predictions. And outside or internal expert will present the curious features of monsoon 2024. And finally, it will be an open discussion among all the attendees. And in this direction, for today, IMD, IITM, and NCMRWF have come together for the first Monsoon Par Charcha. And as an internal expertise, an IITM scientist will join the discussion. And request Dr. Susmita Joseph, Deputy Project Director, Extended Range Prediction, to moderate the meeting. Thank you.
Thank you, Maheshwar. So I welcome all of you to this monsoon discussion. So first, we have the observational features of monsoon 2024 so far. So this year monsoon was very peculiar. So it's kicked off with a cyclonic system, and then slowly monsoon picked up 2 days before its normal date. And then it covered the whole country by 2nd July. So in between, we are seeing some subdued activities in the June. Then there was some severe spells, extreme rainfall events in the peninsular region and northern India. So now we will listen to Dr. Janamani from IMD on observational features so far. So, sir, please start your presentation. So we have 10 minutes for the presentation and 5 minutes for the discussion. So we will allow you when it's 10 minutes.
8 minutes, if you are alert, I will be thankful. 8 minutes.
Yeah. Okay,
yeah.
fine.
So slide is visible, madam?
Yes. Please go to slideshow mode.
I have put it in slideshow. Is it coming? No.
No.
Actually, you have to share the entire screen.
Yes.
Okay.
So when you share, please select entire screen, then you can.
Okay, I'll do it again. Yes.
Please go to the PPT file, sir.
Okay, yes. Coming?
Okay, yes. Please start, sir.
Yeah, thank you for giving me this opportunity. And yeah, it is a very welcome step. We appreciate and we are very happy. So I will be just talking the performance of monsoon 2024 so far. So this is from India Meteorological Department. And so basically I will be covering the as you know, the first is onset and advance, and then the rainfall particularly, and the triggering system, that is the synaptic system. So rainfall, we know that the the spatial and also the temporal. So that will be the target, and then the forecast, as we all work together to give the prediction of the mainly the heavy rainfall and associated hazard, and then the verification, especially the IMD, and also some of the mainly the the our center like NCM, IITM. So that is the summary and discussion. So basically, as you know that the June month we have seen the monsoon touching the Kerala coast around 30th May. So our prediction was almost correct, which was released on 15th May. But after coming to Kerala, you can see that particularly the Bay of Bengal branch had critical issue. So it did not move. You can see forcefully it could come to Sikkim around 31st May. Whatever was there up to 31st May, that was there. That's all. But after touching Kerala, the Arabian Sea branch could come up to right up to Mumbai around something like 9 or 10th June. But the Bay of Bengal branch remained struck up, just over the sea off Andhra Pradesh, Odisha coast. You can see 31st to 19 June, there was no advance actually in the eastern side. So that resulted the, East Central India and including Odisha, delayed by 1 week. And you can see I have written that Arabian Sea picked up. Arabian Sea had some hiatus from reaching after the Konkan. There were some another 10 days or 12 days hiatus was there. But major, the Bay of Bengal branch was very weak in June. So in June, up to 19 June, from 31st May to 19 June. But later, as we have seen, the monsoon picked up and covered the entire India 6 days before as well. So that is the thing. Regarding the rainfall with the time, when it covered the entire India by 2nd July, before that, rainfall continuously, if you see few days like 5 to 8 June, something was there. But major rainfall started higher than the normal we could get from last week of the June, around 27th June. So it has not, impact much the agriculture, because the last week of June is very crucial, first half of July. So that is the right time when rain picked up. And rain picked up so well was that it was sometimes, 50% or 7% more than the normal. But as you know that this part was dominated by the heat wave, complete North India and Central India. So I'll not go to detail. But what I want to say that monsoon, whatever was suffered in June after 21 June or 25 June, it was well picked up. So that was the one thing. And if you see the further progress, July really was good actually. Some of the weeks I will be showing they were really excess, more than 2 weeks were more than 44% also in July and August. There are some weeks. So you can see this line actually, it is the normal and actually you can see. So the performance was till something like 8 or 9 August. After that, the rainfall was weak actually, weaker, less than the normal. So overall, if you see, it is a fantastic monsoon. You can see, only deficient is actually 33% minus Punjab, but others are just marginal. But what you see, 2022, 2023, that is not there. That footprint, trying to, our monsoon trying to, make up for that, I want to say. There are some subdivisions which are very, very higher than normal, excess or something like that. I have noted also like 74% West Rajasthan, like interior Karnataka. You maybe remember, interior Karnataka and interior Maharashtra 2023 suffered a lot actually, the pulses and others. But this year the situation is very, very encouraging. This is the core monsoon zone. As I was telling, for last 10 days the rainfall has been normal or below normal. Otherwise, during July and August, it has been excess or normal. So overall, June was below normal. July was more than normal or near excess. August again almost footprint of July. So that is there, and overall plus 3.7. Week, as I was telling, June suffered till, something like I can tell 26 June. But thereafter, monsoon recover. The deep blue is the week by week. You can see 3 weeks, particularly 3rd July, 24th July, and 7th August. These are the week when we had a low pressure system. In fact, 24th and 7th August, we have depression actually. This is a depression, this is a depression. We know, so rain was high. So overall, from something like minus 19%, it improved, up to plus 4%. What was there in the 26th June actually. So that was there. And this is the month of the June. You can see continuous daily rainfall, pan-India. So, and you can see the area, large area, almost northern half of India was deficient. Coming to the June overall activity, we know that MGO, also contribute. So you can see it was in the Western Hemisphere, this blue color, most of the day. So that was there. And if you see there was no, low pressure system, only one was there during last week of the June. So, so that is the things. And coming to the total system, it was only 3 days actually, whereas normally 11 days. And I told that Bay of Bengal remained weak, very weak actually, low level jet, whatever we were getting, mainly from the Arabian Sea. And that's why heavy rainfall mostly confined to the, Sikkim area and Northeast India. Few in the last week over West Coast. Nothing in the Central India because monsoon was advanced till up to, I shown also that only in the last week it advanced also. Coming to the Northeast India rainfall in June 12 to 20, we have reported flood and some exceptional heavy up to 64 centimeter over that Northeast India. And now in the July, it picked up very well. From June 25, in fact, it picked up. You can see in the July, we had excess rainfall, large area of the central and peninsular India. Some of the area excess went up to 75%, particularly Konkan, Goa, Madhya Maharashtra. We know how it has been rained in Pune also. That shows how much excess it was. We know how, Gujarat, all 3-4 cases reported exceptional heavy rainfall. So you get, I will tell that super excess actually, very high rainfall in July you get in this belt. District-wise also similar footprint. Seasonally, it was improved. You can see large area deficient was make up actually by last date of the July, overall 9%. One can see extremely heavy rainfall. As we know, there was chaos in the Bareilly and other area due to rain-related flash flood. Even
8 minutes over.
over. So I'll just directly. So this is the July, and then coming to the July, as you know, the things, the force or the features, they return back. You can see all the days it was in the Eastern Hemisphere, MJO, and there were 3 systems. One was the depression. You can see the depression crossing actually the Odisha coast. So they were favorable. So August, if you come, August first 10 days was very good actually. One can see we got a depression right over the, something like Jharkhand. And then you can see the rainfall actually August. But point is that, whatever July rainfall we had over Maharashtra or all those, West Coast, it has suffered because we don't get much crossing from the Arabian Sea in August, after 10th August mainly. So one can see the overall, it remained plus 4%, but rain reduced, which was there till July 8 actually. So that was the August rainfall still 8.2. So we are expecting a system to form around 25th over northwest. So that will revive. August will remain around 7 or 8 actually. So that was the things. So these are the August features. You can see NGO party was, unfavorable also. After 7th August, you can see it was over 8 and 1. But this season is very, prominently seen when you see the absence of the routine low pressure system. In June, it was only 1. July, August, it was below normal, as you know, and total days are also very less. So September is there. So I want to see how these systems are making up. Heat low July was favorable, but August was higher than normal. This date is August actually. This date is the normal of the heat low. You can see many days August heat low is higher than normal, the pressure. So if you see the distribution wise, 2024 is fine actually. If you see it, really a good monsoon comparable to 2021. I do not know. We are still left by 40 days. So I will just show the low pressure system depression. You can see how the all the favorable features were there, and that's why we were getting regular rain. So models were good. But this is another depression which crossed actually, which formed over the Jharkhand. can see wide area receiving rainfall in the August also. Coming to these last 10 days, we get, zero pressure gradient along August, along west coast, Bombay and Trivandrum. This is 19 August, you can see. And last after 11 August, rainfall missing over west coast, including Bombay and others. You can see the Bombay heavy rainfall, no heavy rainfall after 26 July, only 1 day was there. So that shows a wide gap. But whatever rain has high rain, still continuing excess. So if you see our prediction, long range forecast going well. Still, if you see, we predict 106, 104 we are running. Interesting is that, homogeneous region is coming fantastic, correct. If all goes well, you can see whatever area, like 94%, 80%, like 180 northwest, 100, you can 106, 109. Coming to June, especially the models are predicting, this MME monthly rainfall. You see the deficiency it able to capture June, able to capture, and then July also partly, August also capturing, west coast and Gujarat. Coming to the prediction part, I just want to show this. If you see operational, we are getting up to day 4 from 0.88, 0.69. So this is actually POT CSI. GFS is 0.65 going to 0.56 actually. Day 1 to day 5. ECMWF near. Income, as you know, because of the wet bias, the heavy rainfall only, it's really showing a good skill. But I will only look for special also. So if you special, you can look this slide actually. You can see the red means you are 70 to 80% correct. This is operational. All different score day 1, day 2, day 3, day 4. So like that GFS day 1, day 2, day 3, day 4, day 5. Like that income day 1, day 2, day 3, day 4, day 5. So if you see, actually models are also doing well. And as I was telling, there is a wet bias. So that's why the comparison is there. Other models are very low. And we have also MME. It is coming near about GFS actually, because these models are in our MME. So that's why it is reducing, that skill also. So that I just wanted to say. It is going well. So all depends, And another thing, as you know, that whatever we thought, Lana will take over. So that did not happen actually. Still transitional. I saw the diagnostic bulletin also. So it will take time the La Nina to come out. But still monsoon is doing well. So if any specific question will be there, then I would be very happy. Yeah.
Thank you, sir. So, are there any questions to Dr. Janamani? Yeah.
Yeah, Janamani, this is Surya again.
Yes, sir.
So this July rainfall, when if you look at it, the distribution is very uniform throughout country. Whereas when it comes to August, it is very patchy and mostly convective maybe. So is there any teleconnections associated with this, or why July is so large scale rainfall is very?
Yeah. So as I, sir, I was not having the time, but I can tell, July, you had all the days, all the features like east-west shear line is there, supported by the monsoon trough south of the normal position, monsoon trough running many days, like it comes up to, even Ahmedabad and coming down to Vizag also. So that was the situation all through the July. So you have all the basic features were there. So you got, and another thing I must tell that, the Western Himalaya or Eastern Himalaya, you do not have a, that kind of high rainfall activity all through the July and August, as I was showing. So that was mainly the reason was this actually. When you have active monsoon condition continuing so many days, so naturally, you will get the rest of India, but you may not get, that area actually. So if you see the initially, we were not having major heavy rainfall spell in, Western Himalaya, your Jammu Kashmir, Punjab, Haryana, all these areas. But whatever you are getting, very high rainfall. So that is actually, even though, towards the July end, you reduce it to 9%, but it remained, 11%, 12%, it was maintaining the July rainfall. And if you come back to August, up to August 10, if you see, the total 10 days rainfall was going up to something like 30 or 40% actually. So that was the activity from, I will tell, from June 25 to August 10. So that we have to look, that intra-seasonal variation, and suddenly from August 10 onward, everything stopped actually. You do not have a system, any system in the Bay of Bengal, and your Arabian Sea, how it collapsed actually like that. You do not have any rain, the Trivandrum which occurred, Kerala. So Kerala rainfall occurred on July 30. So July in Kerala was never having extremely heavy rainfall. Only the July 29-30 till July 30 AM. It was the only date having extremely heavy rainfall over July. The rain was so much to the north of the west coast. It was mainly restricted to Goa to Gujarat. I was telling in my beginning, a very high rainfall bias you could see in July occurring from Goa to Gujarat, actually even Kutch area. So that was the July pattern. So overall, if you see, the distribution has been very good because I have never seen such August where even though you do not have a major system in August 10 to August 20. So if you see like Northwest India, we got first major spell in August 10 to 20 because monsoon trough was normal, and the northern half of the India received major rainfall from 10 to 20. So you are very correct. Actually, somewhere rain was missing for 10 days. Next 10 days it was adding. So uniform was there because of the first July to 10th August, it was because of the system. But from 10th August to 20th August, Northwest India have good rainfall because of the monsoon trough near Namba.
Okay, thank you, gentlemen. Yeah, thank you.
Yeah.
So any other questions to Dr. Janamani?
See, I was
YouTube?
showing,
Comments?
yes, sir.
Yeah,
Yes, sir. I was showing,
Yeah.
I was just showing for you, our scientist. You can see this is August 19. Can you imagine a ISO line coming from, something like Asura right up to, Kanyakumari. So that is the situation, developed during August 15 or August 12 till 20 actually. So this is the, surface actually. And when you come to the 925 HA, this is wrongly 925. This is surface actually. These are the, heat kind of low, what you talk about convection actually. And we get a low here. But you never get, a low over Karnataka. You get a low over.
Janamani.
Yeah.
See, there are some more questions from YouTube. So
Yeah.
we be brief about them. So some of my colleague Mahesh will read out for you.
So there is a question from Mokopadhyay sir. The question goes like this: the Gangetic angle is minus 20% almost at the end of August. Last 2 years also the Gangetic Bengal has severe deficit. Any reason for that?
Yeah, that I told. This is last 7 days. I have not taken up to 20 days. The week actually, this is 1 week when we suffered actually minus 14%. And I am sure the week ending today, the 21 August, we will get similar, maybe minus 15%. So that's why, wherever you have gone up to 108 or, all India, it is coming down. So it is mainly because that happened actually. Monsoon variation is like that. You don't expect all the 3 months to be active actually. So, but interesting is we do not have a break till actually.
I think the answer is clear now.
Yeah.
So there is a continuation question into that. So who is leading in this region, and the excess of more than 85% of Tamil Nadu was predicted in the seasonal focus. So we'll see the seasonal focus later, I think. So yeah, it's okay. I think the question is answered. Okay, thank you, sir.
So thank you, Dr. Janamani. So now we will move to the next talk by Dr. Angur Gupta, who will be talking on the seasonal prediction. Dr. Angur.
Is slide moving? Yeah,
Not
hi.
moving.
Try to move it.
Yeah, no,
Okay,
yes.
Yeah, so good afternoon, everyone. So I'll be mostly talking about the seasonal prediction of the monsoon thus far and what is the seasonal prediction of the next coming 3 to 4 months. These are the slides with the input from IITM, and so I'll be showing the NCMWF and IITM model forecast and also some of the global centers. So because the El Nino is and so is the most dominant factor of the variability of Indian monsoon at seasonal timescales. Let us see what are the conditions of SST in the equatorial Pacific region. So you can see the average SST anomalies daily from 5 average over 5 north to 5 south. As we can see from beginning in September to 23rd to December, there was a strong El Nino, and the transition, at least in terms of the SSTs, we can see the appearance of the cold anomalies in beginning from May and June 2024. So if we look at the recent SST anomalies, especially all over the tropics, we can see that the tongue of cold temperature anomalies can be seen in the particularly in the Eastern Pacific region, and warm SST anomalies can be seen in the Western Pacific region, although the Central Pacific region, Central Equatorial Pacific region is very near to the normal. So although these SST anomalies, cold SST anomalies have started to appear in the Eastern Pacific region, when we are doing a 3-month average, the index is called like ONI. This is the 3-month average of 3.4 SST anomalies. We can see that if we do that, then the temperature anomalies are still warm. As you can see towards the end of the x-axis, the orange color peak in 2024. But if you look into the subsurface, which is shown the temperatures of 3 pented mean temperatures in the equatorial Pacific region, we can see that from 17th of June to 1st of August, large cold anomalies are already present in the subsurface. And from 17th June to 1st of August, these cold anomalies have started to crop up near the surface and beginning to show their influence on the Eastern Pacific. This is also the same information we can see when we compute the heat content, which is the second row on the left panel. We can see till December 2024, because of the pre-existing El Nino conditions, the warm heat content, upper ocean heat content anomalies were there. And from beginning of January, the subsurface ocean is suggesting the cold SST anomalies, although the surface is still towards the warm SST anomalies. Similarly, the same robustness of the developing La Nina from transition from El Nino to La Nina conditions can be seen in the thermocline changes, which are negative in the till December 2023, and from January 2024, they are beginning to have a downward slope towards from the east to the Western Pacific. So the conditions are near neutral, but they are the background conditions in the Pacific Ocean are consistent to have developing La Nina kind of.
Ankur, can you please pause for a while?
Sorry?
Yeah, actually there was some technical issue, so just kindly hold on.
Yeah. Hello?
इसको कनेक्ट करो, HDMI केबल है?
Any problem?
Just a minute.
Yeah, actually there was some display was not coming, so just
Then that problem is there. Yeah, today
Project, right? Second September. Start कर दो. For that. Those will have. Joy. हमारा टीम. Site. Yeah. But the only.
Yes, project नहीं है.
Yes.
जाने से हो गया.
It's okay.
आपके पास.
Okay.
Now we can hear it.
That YouTube was. Okay, sorry for the technical issue. So Ankur, please continue. Sorry for the delay.
It's okay. So I think the
Go ahead.
Their system is. Their system. How does that?
Any issue?
we can you hear me?
Ankur, your audio was not there.
On.
On hold हो गया.
नहीं चल रहा है. बोलो कुछ बोलो.
Hello, can you hear?
We can hear you. Go ahead.
We can hear it.
Okay, I'm sharing it again.
Just need to select this. ये गलत बोल. आपको select करना ये वाला. Ready. Go.
Yeah, are the slides visible now?
Hello. On hold. On hold कौन कर रहा है? हम तो on hold नहीं है. On hold. Hello. Hello. हम की वीडियो स्टिल है ना? हाँ सर, अभी आप पूरा स्टिल है, आपका पूरा स्टिल है।
और अच्छा वीडियो
हाँ, कुछ चल नहीं रहा, हमारे साइड से तो चल रहा है। Okay, go ahead, go ahead.
Yes, अच्छा. Now can you hear? Can you hear us? We are not able to hear them.
Okay.
Hello? Can you hear us?
Yeah.
Yeah. Now, okay. Now my slides
Okay.
and my voice is there.
Yes, please go to
Yeah.
the previous slide.
Okay.
Fine.
Yeah, go ahead.
Yes.
Okay, so I was discussing that the 3-month mean surface temperatures are indicating still warm anomalies, although the daily SST fields have started to appear in terms of the cold SST anomalies in the Eastern Pacific region. But as you can see, the background when we see at the subsurface from 17th of June to 1st of August, the subsurface ocean, the background conditions are very well there, and the large cold SST anomalies are existing in the equatorial Pacific Ocean. And from June towards August, they have started to crop up towards the surface as well. So in the going further in the next few weeks, we can expect the SST anomalies to strengthen in the Eastern Pacific. The signal of cold subsurface is also seen when we are seeing the upper ocean heat content, which is the second row on the left panel. So as we can see till December 2000. So as we can see till December 2023, there is a warm heat content anomaly. And from beginning of January 2024, there are cold heat content anomalies that started to appear. This is also the robustness of the background La Nina kind of conditions are also existing in the thermocline flows. And beginning from January 2024, we can see that the thermocline is sloping, dropping from the east to western equatorial Pacific Ocean. So, how does the model work forecasting these conditions?
Mahesh,
Yeah, we can hear you.
Mahesh, can you mute your mic?
Okay, so yeah, if we see the how the SST anomalies were forecasted by the different models, first let us look at the MMCFS. So as we can see that from the June initial conditions, the July, August, September forecast was correctly of the negative SST anomalies in the Nino 3.4 region and the Eastern Pacific. So the probabilities of transitioning from El Nino to La Nina appearing in JAS is quite high, 70% for the case of MMCFS. And MMCFS version 2 is also indicating negative SST anomalies in the Eastern Pacific region. Although if we see the intensity of the anomalies in the plume plot towards the bottom right portion of the screen, we can see that for the July, August, September, the magnitude of the SST anomalies forecasted by the CFS model is between 0.5 to -1 degree Celsius, which is slightly more than what we are currently seeing. So if we see the NCMRWF forecast of the plume plots and the SST anomalies valid for July, August, and September, we can very well see that the negative SST anomalies started to appear in the Eastern Pacific region, although the intensity of the anomalies are slightly stronger than the MMCFS, but they are within the range of 0.5 to 1 degree Celsius if we do the 3 months mean. Another point to notice over here is the forecast, the confidence in the forecast of La Nina is much more in the NCMR forecast than the PFS. So the probabilities of forecasting La Nina conditions for the JAS was more in the NCMRWF forecast. So if we compare these, the forecast of particularly for the July, August, and September, we can keep in mind that currently we are seeing the El Nino neutral kind of conditions, and the model were indicating slightly more confidence in transitioning to La Nina conditions in July, August, September itself. So the forecast of the CPC with the panel on the left, we are seeing the forecast of the probabilities from different initial conditions. From the top is April, then May, then June. And if we just concentrate on the JAS forecast, we can see the 70% probabilities were there for transitioning in July, August, and September to the La Nina kind of conditions. This has reduced to 60% in NOAA CPC. But if we look at the IRI forecast, these set of forecasts are definitely indicating low probability of transitioning to La Nina condition, and high probability or equivalently high probabilities of around 45 to 50% probabilities of maintaining the neutral conditions, which we are currently seeing. As we are coming closer from the April forecast, which are the top panels, to the bottom panels of the June initial conditions, we are seeing that for the JAS forecast by all the models, be it CFS, NCMWF, or the set of forecast by NOAA CPC or IRI, the probabilities, particularly if you see the IRI forecast, the probability for JAS has reduced to 30% of developing into a La Nina kind of conditions, and the probability of neutral and so conditions have increased to 60%, so which is closer to what we are seeing right now. In terms of the absolute anomalies, the intensity of that, these are the set of IRI models, and the green line, the dark green line is the average of the statistical models, and then the magenta lines are for the mean of the dynamical models. We can see the statistical models are predicting less cold anomalies, although they are also indicating the developing into the La Nina kind of condition. So these features are consistent. These are the verifications since March initial conditions. And again, if we look at the June, July, August, September, then the models are indicating slightly more colder SSTs and early transition to La Nina than what we are currently seeing. So if you look at the another factor which usually impacts the Indian monsoon, particularly when the ENSO is neutral. So in this year, the El Nino is definitely transitioning from a particular phase to another phase. So probably IOD is may not be able to impact the rainfall. Another reason is another fact is that the forecast of the IOD itself is changing as the season is developing. So on the top, we can see the forecast of different models. They are indicating the positive IOD conditions in September, then a combination of negative and positive IOD conditions in October, and same as well in the November. The bottom panel is the forecast from CFS, and these are the April initial conditions. We can see the model was indicating positive IOD in April, and then the negative IOD conditions in the May, and even more negative IOD conditions from the June initial conditions. These change in the IOD forecast and the sign is similar in the NCMWF model. It is also showing that with different initial conditions, different phases of IOD are forecasted. So this time there is less highly uncertainty in the sign of the IOD developing in the nation. This is the composites of rainfall that what we expect to see in a normal El Nino and La Nina condition. So if we see the right-hand plot, which is for the La Nina composite, we can see basically we can expect during a developing La Nina conditions more precipitation over India, but a north-south shift of the headley circulation, because of which the more rainfall anomalies north of the equator and the negative rainfall anomalies just south of the equator. Plus, there on the southern Pacific convergence zone, we can also expect to have a higher rainfall anomalies. This is very similar to what the forecast from the June initial conditions of the JJS for this season. We can see the rainfall anomalies forecasted by the model is above normal over the Indian region, as well as the band of northwest shift in the rainfall anomalies can be seen in the entire equatorial belt of the Pacific Ocean, and the rainfall impact on the southern SPCZ is also we can see. So if we see how the NCMWF were forecasting these developing conditions, impact of the ENSO on the rainfall. So these are the April initial conditions and the verification for the season which have just realized May, June and July. The forecast was of above normal conditions in the northwest regions of the India, and even higher probabilities of not above normal conditions in the southern peninsula. If we look at the observations, how the season has realized, we can see that the observations are also indicating the slightly higher probabilities of above normal conditions in the southern peninsula, which is very well matching with the probabilities forecasted by the model. And similar to the model forecast, the northwest region is showing more probabilities of above normal conditions, which is there present as well in the observation. Although if we see that in the East Indian region, the Jharkhand and the West Bengal region, the model is indicating near neutral conditions. Although what is realized is the negative rainfall anomalies or below normal rainfall over that particular region, which is not captured by the model. Although it is not indicating above normal conditions, it is just indicating the near normal conditions. If we see the anomalies, same, although there is a slightly northward shift of the rainfall anomalies from the NCMWF model forecast, but what is the main lacking is the negative rainfall anomalies over the West Bengal, Bihar, Jharkhand. So above, beyond that, the all India rainfall averages and the forecast over the northwest region, the southern peninsula region were very well captured by the model in the April initial. So if we come to the June initial conditions, the model maintained above normal conditions over most of the region. But if we look at the monthly mean rainfall anomalies towards the right bottom panel, we can see the July and then the observations of July from the IMD observations anomalies are also shown in the central plot of the screen. So we can see that over the west coast and over the parts of the central India, southern peninsula, the above normal rainfall has been realized, and the model in the July is also indicating more rainfall anomalies over the west coast parts of central India. Although again here the highlight is that the negative rainfall anomalies over the eastern parts of the eastern country, eastern states were not captured by the model. The above normal conditions were all maintained even in July initial conditions, and if we see the rainfall realized till 21st of August, in the central plot on the screen, the observed rainfall, we can see the northwest region is showing the above normal anomalies, and then the southern peninsula, parts of southern peninsula is showing negative rainfall anomalies. This similar structure is seen in the August forecast from the July initial conditions. The model was indicating above normal conditions in the northwest parts of the India, although it was not showing the negative rainfall anomalies which we are seeing over the parts of eastern India and the central. So going forward, the forecast for the September, October, November month-wise over the entire tropical region is we can expect because of the likely transitioning to the El Nino conditions, the September rainfall to be above normal over the entire country. And moving towards the October, we can expect to have a late withdrawal of the monsoons, which we have quite high confidence in these conditions to be realizing. But if we see the pattern in the equatorial Indian Ocean, the forecast is changing from the positive IOD conditions to transitioning to a mixture of IOD type of conditions in the October and November. So the impact of IOD, we are uncertain right now what would be the IOD conditions developing. So in terms of the temperature anomalies, the forecast was of below normal, high probable, near neutral, near normal conditions in most parts of the India. And in terms of the anomalies, the cold anomalies were forecasted for both the seasons, Jas and August, September, October. So this is just a few of the summary slides. Basically, we are experiencing ENSO neutral conditions and high confidence is there in transition to La Nina. Instead of August, we expect to see the transition in September now, and all the models were indicating the correct impact of the La Nina over the Indian monsoon and above normal conditions for the June, July, August, September. Although there are some regions where the model were not able to capture the rainfall anomalies, particularly over the parts of East India. So thank you.
Thank you, Ankur. So, any questions to Ankur?
Okay, Ankur, very good presentation. So, and almost all models are showing now September rainfall will be above normal. So, which is going to contribute to that? Because La Nina conditions are not going to be normal.
Yeah.
So you have neutral and so. So what is that going to contribute?
Yeah, the La Nina, so the monsoon has been robust so far with the exception of few areas. So we expect even in the absence of the strong ENSO signal, the monsoon to be near normal, but the above normal conditions are likely to be contributed one by the transitioning of from La Nina to El Nino to La Nina is being forecasted further in September. And the negative SST anomalies are already appearing in the Eastern Pacific. One is that. Second is the IOD is also uncertain. In at least in if we see this model in terms of the equatorial rainfall anomaly, the dipole in the September is clearly visible. So at least in model, the above normal condition over the Indian region is also contributed by the presence of IOD for the September for the month of September. So those are the two reasons which, because of which the model is indicating the above normal conditions for the September. Whether it is realized or not, we can't say.
Okay, thank you.
So there is a question from Mukhopadhyay sir again. So in continuation to earlier question, whether the Tamil Nadu excess was captured by seasonal prediction or not. And second thing is whether the negative rainfall anomalies over Bihar and Bengal region is related to any large scale driver. If so, why the models are failing to capture this?
Yeah, so the Tamil Nadu in which month? Tamil Nadu rainfall.
So month he has not mentioned, but it is above 85% excess.
Whether it was above normal in the model itself, model in.
Yeah. Yeah, if we look at the May, June, July, then the model is indicating the above normal conditions in the southern peninsula, Tamil Nadu, and also Tamil Nadu. So both in terms of the probabilistic forecast and also the rainfall anomaly.
Can you elaborate?
So he was asking for JJ season.
YouTube itself, you can give.
So it's showing, I think, Tamil Nadu excess is reflected in many of your prediction. The second question is over Bihar and Bengal region, whether the negative anomalies are captured. And if these are related to any large scale drivers.
Yeah. So this first of all, the rainfall, negative rainfall anomalies over this Bihar, Jharkhand region has we are seeing in the recent climate change rainfall anomalies there as well. So which is unrelated to the seasonal forecast, but there's a tendency for the observations to have negative rainfall anomalies over there. So which is we are seeing in this season as well. Another thing is the forecast. I have seen in the last 3-4 years, whenever there is a negative rainfall anomaly over the region, models at seasonal timescales at least are having difficulty in capturing that signal over the eastern parts of the Bihar Jharkhand region. The reason is first of all we do not probably understand all the drivers which are driving the rainfall anomalies over there, but there have been recent studies which suggest that the drought-like conditions are because of the lack of soil moisture, and it is feedbacking to the rainfall, local rainfall anomalies over there. So probably we need to look at about more than the large scale teleconnections, because that would have been indicated by the ANSO and IOD kind of conditions. So if something is particularly happening over that place, at least there are some studies which suggest that the soil moisture conditions are being like they could negatively contribute over the local rainfall anomalies over there. So which then suggests that we need to look at the soil moisture forecast of our how good the quality of our soil moisture conditions, and the initialization of the soil moisture and all those conditions are still a challenging things. Although at NW timescales, at least we have good like data estimation and the soil moisture conditions are good, but how they evolve over the season, that needs to be looked at.
Okay, thank you, Ankur. So let us thank Ankur for a nice presentation. Now we will move on to Dr. Akhilesh Misra, who will be talking on the extended range predictions.
My slide visible
Yes, yes.
is, sorry. Please let me know if it is.
Slideshow mode.
Okay, oh yeah.
Tap the
This one. Fine.
Yes,
Visible now?
fine. Yes,
And
yes, fine. Please move the slides. No, it is not moving.
I've not started moving. 1 minute.
Okay, okay, fine.
Moving now?
Yes, yes, fine.
Okay.
Yeah, please go ahead.
All right. Thank you very much for inviting us. And it's nice to see that, that Aryabhatta Hall after 20 years. Thank you very much once again. So I'm going to show the extended range predictions from two of the MOES forecasting systems. So to start with, the IITM is using this multi-physics framework and their ERP version 2, where they're using simplified these convection, a mix of convection and microphysics, and with the different resolution setting as well. So these seamless horizontal resolutions options are used. The combination of these are providing 6 kind of multi-physics option, and using the perturbations altogether 18 member ensemble member multi-physics multi-ensemble forecasts are generated. And this is basically supported by initialized by ANSI model of atmospheric condition, and QIS provides ocean and initial conditions. And that's how the whole setup is experimental setup is explained in this chart. So what you are going to show in next slides are the based on 17th August initial condition, the forecasts from this ERF version 2. So this is multi-physics, multi-ensemble actual rainfall initialized forecast for week 1, week 2, week 3, week 4 from this forecast system. And as you can see, this is full field, and the right side you are seeing the anomaly. And anomalies are showing that there is a possibility of development of a low pressure system over Arabian Sea, which was also realized seen in the GFS forecast in NWP today morning map discussion with IMD. And they are more or less showing above normal rainfall for entire mainland except the Western Ghats. And in the week 1, week 2, it shows there is a Indo-Gangetic plains and northwestern part of India is going to receive above normal rainfall. Week 3 and week 4 are showing signals that not rainfall is going to be near normal to above normal, most part of the country. And if this is very nicely put in a homogeneous region. If we bifurcate all the rainfall and try to show the probability of percentage probability of occurrence of rainfall, you can see that over these 5 regions: Central India, Monsoon Zone India, Northeast, Northwest, and SPI zones. So week 1, week 2, week 3, week 4 forecasts are shown here. Above normals are in the blue color. As you can see that monsoon zone and Central India, which are more or less having many area common, are showing above normal rainfall in all week 1 through week 4. Whereas Northeast is going to pick up most probably is going to be near normal or above normal most of the time, except in the week 2 that shows the probability is there that to remain the below normal rainfall. Similarly, Northwest and Southern Peninsula also shows a above normal rainfall in most of the weeks, so which was also realized seen in the previous spatial map. So if this shows the time series from August up to next 4 weeks, multi-physics MPME time series for rainfall percentage anomalies over monsoon zone, and initial condition is 17th August once again, and the bottom plot shows the equatorial Indian Ocean, 5 degrees south to 5 degrees north, between 70 east and 95 east. You can clearly see there was a below normal rainfall over the most period of, it's going to be most period of the August. September, it shows again some above normal rainfall, whereas on the monsoon zone, it shows good amount of rainfall. It's a time series, by the way, it's not, it's daily precipitation. And this is a very nice plot which shows the probability of categorical rainfall forecast over meteorological subdivisions and for next 4 weeks. And you can clearly see that probability of more than 20% or equal to or more than 20% is very high over this most part of the country, except for some parts of Northeast and Gujarat and Western Ghats in week 1. Week 2 shows Central India, Northwestern part of India is showing above normal, whereas the green color shows almost minus 20 to 20, which you can say the almost near normal conditions. Red ones are almost below normal, so that shows that peninsular India, parts of Tamil Nadu and Kerala and Karnataka and Northeast may receive below normal rainfall. Week 3 is once again showing the above normal in most part of the country, all categories, whereas except Odisha and some parts of West Bengal. Week 4 shows the signal that northwestern part of the country may receive below normal rainfall, and whereas the categorical rainfall shows that Indo-Gangetic plains and many parts of the peninsular India may receive above normal rainfall. This is one way of interpreting the rainfall. So now seeing the temperature forecast from maximum and minimum temperature, you can this is showing full field of maximum temperature for next 4 weeks. And this shows the anomalies. So above normal temperatures, maximum temperatures, daytime temperatures are predicted over most part of the central India and western and peninsular India as well, except Tamil Nadu, and some parts of northwest India may receive below normal temperature experience. Week 2 shows below normal temperature over central part of the India, except western part where it may may have above normal maximum temperature. Week 3 and week 4 are having very weak signals, but they're still showing that temperatures may be below normal in most part of the countries. This is minimum temperature, which is on the contrary, where we saw the week 1, week 2, most part of the maximum temperatures were showing below normal. Here, minimum temperatures are showing above normal in the week 1, and many parts of the country in week 2 and week 3 may also experience the below normal temperature in minimum temperature. By the way, this is morning temperature. So, and week 4, you can see that except the Indo-Gangetic plains and some parts of North and Peninsular India, most parts are going to experience forecast is there that it is going to be below normal. This is one good product which tells you about the cyclogenesis and the probability of the low pressure formation of low pressure systems based on initial condition of 17th August. MPME forecast from IITM ERPB version 2 shows that the probability of 80 to 90% chance of this low pressure system formation and movement in the week 1. Week 2 also there is clear sign, which is sign that probably monsoon depression and monsoon trough is going to be in this location. Week 3 also shows some shift in slightly northward side. Week 4, by the week 4 it is very weak. So this is a very interesting product. Of course, this is also useful during the monsoon season, during the tropical cyclone season as well. This is a verification chart from some of the previous forecasts during the onset time. Monsoon onset over Kerala was declared by IMD on 30th May. And you can see what you're seeing here is black color is the observed precipitation over at box over Kerala, and 74 to 78 east and 8 to 12 degree north. And the red color is basically your extended range prediction by IITM based on initial condition of 18th of May. And that you can clearly see that it's just missed by 1 day, but it was still the signals were very nicely captured. Other patterns were nicely balanced. This is a subdued rainfall during the target weeks of 2nd to 8th June. What you see here in the top left is the observed rainfall. Blue color, of course, shows the above normal, whereas red is below normal. This peninsular excess rainfall over above normal rainfall over peninsular India is nicely captured by this MPME June 1st initial condition week 1. Week 2, it was near normal, of which it was signals were not there, but week 3 again there was some the signals were there. Whereas in the 16th to 22nd June, the dry phase over the Western Ghats were nicely captured in the week 1 and week 2, and below normal precipitation over many parts of the central India and North Indo-Gangetic plains were also nicely captured. This is active phase during 14th July to 20th July. This was observed rain. The active phase was basically in the peninsular and central India and some parts of the Western Ghats as well. Whereas Indo-Gangetic plain was experiencing the below normal rainfall, which is nicely captured even up to week 2. Whereas slight shift is there. This active phase is slightly shifted in the week 3. This is the below bottom panel, which are showing the Wayanad, rainfall, which triggered the Wayanad landslides. This is week 1 forecast, week 2, week 3 forecast, which clearly nicely captures the intense rainfall even in week 3 forecast, which caused this Wayanad during 29th and 30th July. So this was all about the ERP system, which is basically being under experimental system, which is under test by IITM. Now I'm going to show the NCR module of ERP system, which we have operationalized 2018 onwards, and it runs with 60 kilometer atmosphere and 25 kilometer ocean model. And we're using model climatology based on 23 years hindcast data, which is shared with IITM as well. For the some joint studies, we are using ensemble strategy, which uses lagged initial condition and stochastic physics. 7 members hindcasts are generated for each month, 1st, 9th, 17th, and 25th initial condition, and total 16 members forecast using 4 members per day. 4 start dates were generated on each forecast. So Sunday we run 4 perturbed initial condition, Monday, Tuesday, Wednesday, all 4 days. Total 16 members are generated, and on Thursday we create the forecast plots and share with most of the people in this group, probably, and anybody on the request. So this is what, based on 15th August, the last forecast we issued on August 15th, and you can see that the week 1, week 2, week 3, week 4 as the 4-week forecast, the full field, whereas the the anomalies are shown in the right panel. So anomalies are giving you some idea that it's probably going to be week 1 is going to be above normal on the Indo-Gangetic plains. Central parts of India may receive below normal rainfall, which we have seen earlier presentation by Dr. Jainamani as well. And week 2 is probably showing a possibility of some kind of depression formation, low pressure system formation, monsoon depression over Bay of Bengal. Week 3 and week 4 are showing more or less normal to above normal in many parts of the country, except the week 3 shows below normal over parts of West Bengal and Bihar. This is just the wind conditions. Similarly, this is 850 wind, full field and anomalies. We are also generating winds at 700, 500, and 200 hectopascal, and we share with each forecast with the daily group. And this tells you the anomalies of maximum and minimum temperature. We have seen earlier the temperature anomaly prepared by IITM. This is similar way we prepare with the maximum temperature and minimum temperature anomalies, and they are more or less in the agreement with the forecast. Minimum temperatures are showing the warming, above normal, whereas maximum temperature shows some parts, cooling activities in week 1 and week 2, and especially week 3 and week 4. We are also producing many ocean products because there is we are having the coupled ERPS is a coupled system with a very nice NEMO global model at 25 kilometer resolution. What you see here is the sea surface temperature anomaly. Like you can see week 1 through week 4, most of the time, northern Indian seas are above normal, showing above normal SSTs, whereas equatorial Indian Ocean, you see SURFs, and southern parts of the, oceans are showing some kind of some signals below normal. So we are also producing SSTs, sea surface salinities, mixed depth, sea surface height, ocean currents, and they're all put on our website. We're not sending these in emails, but these are also available on our website, and these are generated each week. We're also producing some polar products which are shared on the NCPR website as well for their uses. They use it for some their excursional uses as well. So that shows this right panel shows the sea ice thickness anomalies over Arctic. And for the week 1, week 2, week 3, week 4, with other variables, we are computing sea ice thickness, sea ice area concentration, velocity, and drift as well. This interesting part of this is if you see the earlier presentation by Ankur, week 1 of the most of the seasonal forecast, month 1 of the most of the seasonal forecast were very good. Month 2, month 3 becomes, starts, deteriorating the quality of the forecast. So using the, this ERP system, we also share this monthly mean outlook. It's a 4-week mean actually outlook of extended range prediction, which tells you how the situations are going to be for next 4 weeks. And as you can see here, it's as more or less it shows the near normal or above normal rainfall conditions over most part of the country, especially at the northwestern parts. It shows the above normal precipitation. Temperature, same way, maximum and minimum temperatures also are reflecting the same what we saw. Maximum temperature is going to be below normal in northwestern part of the peninsular India, whereas the minimum temperature will remain above normal. So this is just one verification slide from our recent 2 forecasts. This tells you these are 2 different cases. One is between 2nd August and August 8th. 1 week IMD observed rainfall. Above normal is blue, below normal is yellow. And you can see the week 1, week 2, week 3 forecast from ERP system was nicely captured this this active series. Of course, it is slightly shifted in week 3, but still the signals are there. What is interesting to see here in the 9th August to 15th August also, the dry conditions or below normal rainfall observations were very nicely captured in week 1, week 2, and week 3 from our forecast. So that is all from my side. I hope I have not taken much time. If there is any question, I shall be happy to answer. Thank you very much.
Thank you, Akhilesh. So any questions? Okay.
Guruji जरूर पूछेंगे.
Hello,
नमस्ते
Akhilesh.
नमस्ते sir.
Namaste, Akhilesh. Yeah, nice presentation. See, I was curious to see, the July last week extended range prediction by NCMRWF.
July
you didn't
last
show that.
July.
Why not event?
That we missed. I was seeing in the morning.
Oh, do you remember that? Could you see that in NCMRWF?
Yes. We were not able to get it in just 1 week before we got it. But week 2, week 3 forecast was not good. So week 2, week 3 forecast was showing the below normal rain.
Fine.
So
okay. But now that's okay. No. Yes, now when you see the IITM system, so you can see that extreme event 3 weeks ahead.
Yes.
And consistently from 3 weeks, 2 weeks, 1 week, you are seeing something. Now, when we estimate the model skill, we never account, this consistency. We always see 1 week skill, 2 weeks skill, 3 weeks skill. But we never see this consistency. I think when you need another test for this consistent lead skills, and if you notice such events, it is important to inform the government agencies this information. Because now they may not take it because we don't have a proper skill to support that. But in many events we have seen, I remember even Partha showing some of the events, some particular events, they are doing good. But when you look at them, the signals were there few days ahead.
Correct.
So like that, this event, when it is showing 3 weeks ahead continuously, and which is also very clear in the first week 1 week lead. I think it is our moral responsibility to inform the concerned people that there is something very certain to happen.
I agree.
I think that skill score has to be estimated and that has to be published.
Yeah. That's, I think, sir, I mean, among all forecasts,
Because the
ERP is one of the best product we have. I mean, we should highlight it even more, and people, especially the stakeholders, should use it. Many private companies and government agencies are using it, but I think still it is underrated, and we have not yet made it more popular. As you say, the operational use should be. I mean, especially IMD people are there. Janamani sir is there. He should use it more often actually.
I strongly feel that there is no point in telling the public that you look at my model, see it was showing that event, but you have to pinpoint this before the event.
Correct.
See, there may be false.
False alarm is okay.
But false alarms will be there. That's okay. But then that's what you have to do, the proper estimations of skill and inform the government accordingly. Thank you.
Answering to your question, actually what we do is that we have calculated the skill scores for the hindcast period. So there we have not seen like for a particular amount of rainfall, because for extended range we cannot expect from week 3 you can get means a heavy rainfall event well in advance. So it can give some indication. So earlier also we have seen some events. It is giving clear indications week 3 onwards. But some events it may not. So there are event-to-event variability also. So it may be the large scale features might have been more prominent during that time. So that's why the model has predicted that.
Another thing I would like to add, Sushmita, I think both our ERP systems are from different modeling framework. And I think we should also work towards ensemble or some kind of merge products which we can have one product out of it, coming out of it. I've seen the drying tendency in our model, week 3, week 4, whereas your version does not have that tendency. So
Yes.
that's something we can work out, grand multi-model or something, even with, combining these two ERP systems. We will talk to about this, coming weeks or maybe.
Yes. That I actually agree with that. Right now, we are not running in parallel with your system, because we have started running the system from 22 onwards. So that time we have run parallelly with the same initial conditions, but because of the space issues and other things, so we are running it on experimental. So we have fixed the initial conditions based on the 2022 year monsoon season, and then now we are, so now at present our forecasts are based on Saturday initial conditions. So the forecast is for Sunday to next Saturday. So it is like that.
Yeah.
So any more questions?
There is a YouTube question or comment from Mukhopadhyay sir again. So the positive rainfall anomaly shown in week 1 of rainfall anomaly over Arabian Sea is not reflected by any cyclogenesis, even with low percentage in cyclogenesis plot. Why it is so?
Yeah, I was also wondering. So today morning I was in map discussion with IMD.
Yes.
Am I audible?
Yes.
Yeah. So I'm telling, today morning I was in a map discussion with IMD, and there was a debate whether they should declare it as a low pressure system. So in GFS, it was showing the low pressure developing over coast of Kerala, as well as in the NCOM it was showing over Bangladesh. So, but in the satellite pictures and saying other upper air circulation, they decided not to declare that as a low pressure system. So I think that when you're calculating the weekly average cyclogenesis, it's not just one day, sir. So to answer Partha sir's question, when you are averaging for a week, then probably cyclogenesis will diffuse. It's probably 1 or 2 day event what you're seeing the rainfall causing because of the low pressure system. So maybe that might be a reason, but we can certainly dig into it and find out why it is not showing in the cyclogenesis plot.
Yeah. Thank you. Thank you, Akhilesh. So let us move on to the next speaker. We are already very late behind the schedule. So we will now hear Dr. Mohan from NCMR WF on the short to medium range forecast. Dr. Mohan.
Am I audible, ma'am?
Yes, yes.
Yeah.
Please switch on your camera.
Yeah.
Please share the PPT.
Is my screen shared? Can you see my PPT?
Not yet. You can share the entire screen.
Yeah.
Mohan, if you have a problem, we can share the PPT from here.
Yeah, I already sent the PPT, sir. Yeah.
Oh, okay.
Want to share it from here?
Yeah, that would be nice because there is an
Okay,
issue with
okay.
my screen.
Okay. This revised one, no? Revised.
Yeah.
PC. Here you can share the window.
So is the PPT visible?
Yes, ma'am. Yes.
Okay.
Yeah, I'll start then. Okay.
Yeah.
Yeah. Good afternoon, everyone. And then I'm Mohan from NCMRWF, and today I'm going to present about the short and medium range products. Though I'm not quantifying the results, but I'll just describe how the forecast and also the verification of some of the events. So going to the next slide. So already Dr. Janamani has talked about the monsoon 2024. So this is the outline that I will just take up two cases. One is the active phase that has happened in the last week of July, and the other one is the recent deep depression that is on the central India and then northwestern Rajasthan part surrounding regions. And I'll talk about the forecast products and then the kilometer scale modeling. Yeah. So I don't go into the details, but overall in monsoon 2024, we had excess normal rainfall over central India and the monsoon core zone. But some parts of the like southeast peninsular India and the northwestern part of India is experienced excess rainfall. This is because most of the although the monsoon has started very well, the early onset because of the Remal cyclone, it has looked at the until the last second week of July, the monsoon is it's kind of a stalling around the near normal, and then it is in the prolonged break kind of a thing is there. When the monsoon is experiencing break, the southeast peninsular India is it's a well established literature that the monsoon or the southeastern part of India would be active. So that kind of giving the excess rainfall over the southern part of India. And the northwestern part of India, probably the deep depression in the last first week of August is contributing for the rainfall excess over that region. So what I am going to do is that I have chosen two events. One is the actual revival that is happened, that is on the last week of July, and the other one is the August first week, there is a deep depression. Those two events I'm going to discuss today. Although I'm not quantifying, I'll just describe how the modeling system has been performed for these two events. Yeah, next slide. So this is this is a short active phase the 19 to 27, but then the peak has happened on the 24th July from the observations. So when you look at the observations, the observation rainfall are on the left hand panel. So this is the merged IMD and then the satellite and CMRWF satellite measure product, that is a 0.25 degree resolution. One can see that rainfall is a typical active monsoon rainfall kind of a thing, where the rainfall band is between the 16 to 27 degrees latitude belt, and then it is all the west coast is connectively active as well as the head bay of Bengal. So this is the feature the large scale rainfall is showing. So when you look at these features in the modeling system, that when you look at this in the NCUM global model, that is a 12-kilometer resolution, most of the features are captured very well. Even the head bay of Bengal rainfall or the west coast and then the central India, the rainfall is. However, the western equatorial Indian Ocean rainfall, there is a slightly overestimation of this region. And then the regional rainfall also shows this has picked up these rainfall pockets. But when you go to the IITM GFS T153, I could see that the head bay of Bengal region, compared to the observation, completely dry or this region. But however, there is a rainfall pockets, and probably there was a shift in the spatial pattern also I can see. But then when you look at the ensemble member mean, I can see this. Some of the members may pick up this observed rainfall pattern of the spatial rainfall pattern. But in the IITM GFS deterministic, I think this head bay of Bengal rainfall is not shown properly. It's completely dry. I think can be seen here. So next. But the same event, when you look at the probabilistic forecast, that's the day one forecast, which is valid on the July 24th. Most of the ensemble mean has picked up this, has shown these events, even in NCMRWF ensemble, as well as the ensemble mean, as well as the IITM ensemble mean. The rainfall pattern has been seen. There are slight shift in the pattern on the northwestern part of India. But when you look at the rainfall different thresholds, the rainfall thresholds of 2.5, and then the other categories like moderate, low to moderate rainfall. Both the systems has been performed, able to capture this rainfall spatial distribution properly well. One thing is that when you go to the higher amounts, this NCUM, the ensemble prediction system has slightly overestimated, or the pattern was slightly not on the exact position. It's a slight shift in the position has been seen in the higher rainfall rates. This is one kind of an issue in the UM, that the lower rainfall rates has been properly accessed, and then the higher rainfall is underestimated has been seen in the UM. Next slide. So this is another during that phase, that whatever I consider that active phase from 19 to 27. When I look at the 27th of July, that is the end of the active phase. I randomly choose this event. There is no thing is that. So when I look at the 27th of July rainfall, when the active phase is about to end its active phase, and then it's going to break. So when this even when I look at the verification of this event, the observed rainfall is seen that the most of the rainfall is only on this part, the central India, and then east central India, and there is Arakan coast. There is a large rainfall amounts has been seen here in the observed rainfall. But then when you look at this observed rainfall patterns in the UM as well as the IITM forecast modeling systems in the medium range, then you can see that there is a large overestimation of rainfall for the oceanic regions in the UM, then the 72-hour forecast, that's the day 3 forecast. And this is also in the 72-hour forecast, there's the regional model, that 4 kilometers, also showing a little higher side of the rainfall. The magnitudes are slightly on the higher side, both on the Arakan coast. But when you look at the oceanic rainfall in the IITM GFS, looks like it's slightly underestimating the oceanic rainfall or these open oceans and Bay of Bengal and kind of a thing. Yeah, next slide. So similarly, the probabilistic also showing the same kind of a thing. When you look at this rainfall on the day 5 the forecast, the probabilistic forecast of the NCUM as well as the IITM, the rainfall thresholds of moderate up till low to moderate is able to is showing very well. But then when you're going to the higher ends, the thresholds, the ensemble prediction system in both the things, you can see over the Gujarat, there is observed rainfall is very low, but then there is a probability it's showing that more than 25% of chances that the probability of rainfall over this region is showing in IITM GFS, as well as some of the regions over the central India in NCUM as well. But this is in the day 5 forecast. Next. This is the deep depression. There is a deep depression that has happened over the central India during the first week of August, that is from 2nd August to 5th August. But then the depression has transformed into deep depression on the 3rd August 12 UTC. So I took that 3rd August 12 UTC case, and then when I look at the track of NCUM, this is the track. This is the predicted track from the NCUM tracker. But when you look at the rainfall patterns, most of the over this track, along the track, the rainfall patterns during this deep depression has been predicted well, both the ensemble as well as the IITM GFS forecast. But the thing is that the probability, probabilistic, the rainfall, the track probability, probabilistic forecast of the track in the NCUM forecast of 1st August. This is the 1st August 24 that is composing for the next 5 days. Is only showing a track up to here, but when you go for the other days, the 2nd and 3rd August, I couldn't able to see any tracks like I have seen in the IITM. Go to the next slide. This is the same track, in the deep depression on the 3rd August and 12 UTC. When you see the track is slightly shift if in NCUM compared to GFS. When you look at the observations. There is a slight differences in the tracks, although I'm not able to quantify this one, but then the tracks in NCUM and GFS is slightly different from the best track. Go to the next slide. What I'm talking about is that this is the probabilistic forecast in the GFS T1534, but this kind of a probabilistic forecast in NCUM probabilistic maps we have not seen in different initial conditions. So only I could able to see the track in the August 1st, that is in 0 UTC. After that, when you go for the different initial conditions, the probabilistic forecast, the spatial track, I couldn't able to see anything, so I couldn't able to compare this track with NCUM ensemble tracks. Next. So this is the EFI. This is the high resolution extreme forecast index product that IITM is generating. I just want to show that the for this particular event, there is a likelihood of along the up to day 3 forecast. This EFI product is showing that there is a likelihood of extreme weather over this region, particularly. So we are also generating the EFI product, but still rainfall is still ongoing. It's not yet operationalized. So that is I couldn't able to see that. Next one. So finally, I want to conclude with the forecast. This is the forecast of day 1 that is initialized on 24 hours forecast. This is initialized today, 21st August. And then the day 1 forecast is showing that the rainfall is probably, I think, it's going into when you look at the winds, most of the winds are going south of the southern peninsular India. That is, it's a kind of a weak monsoon circulation. The circulations are getting weak from tomorrow onwards, or in the forecast. Similarly, the IITM GFS also shows the same kind of a circulation pattern. That means in both the systems, the monsoon is getting weakening, and then you can see in the day 1 forecast. Next slide. But when you look at the day 5 forecast, there is the system that is slowly is picking up, and then we can see a low pressure system over central India, and the associated rainfall also seen over the central India. However, when you closely examine this system position, slightly there is a shift in the systems. In the NCUM, the system is on the western side, whereas in the IITM GFS, it is on the slightly on the eastern side of the eastern side, relatively eastern side. Yeah, next slide. Finally, I want to show that MOS, the IITM high resolution 6 kilometer run. Just want to show you one particular aspect that we are also doing this 6 kilometer runs. Although that is not operational, I just want to see that it is on the same page. So based on the IITM high resolution, when you look at these rainfall maps, in our 6 kilometer runs. There is although runs are very old, as July 2020, the last year monsoon, could able to see that the rainfall pattern, spatial distribution, the ITCZ movement, ITCZ spatial pattern can be seen in very well. So it's not still operational, so I couldn't clearly get the 6 kilometer run from in the monsoon 2024. Next, please. Yeah, thank you. That's all I can stop, and then I can take questions.
Okay. Thank you, Dr. Mohan. So any questions to Dr. Mohan? YouTube, some questions are there? No questions. Okay. Okay. Thank you, Dr. Mohan. So now let us move to Dr. Justi Chaudhary. He will be talking on the large scale features of monsoon 2024.
Good afternoon to all. I'm going to talk about large-scale circulation. Yeah. So now I'm audible. Okay. Okay, so I'll be talking about large-scale circulations associated with 2024 monsoon. So let us start with El Nino conditions in Jan 2024. So you can see that the strong SST anomalies, positive anomalies extending from eastern equatorial Pacific to the central. So it is one of the strongest El Nino of I think last few decades. It is super El Nino. So it's rapidly, you can see that decaying, especially in the eastern parts of the Pacific. And you see that by April, the anomalies are strong for the central Pacific region. And at the same time, Indian Ocean is warmer initially at over the western parts, and then it becomes a basin-wide warming by April. So this warming is induced by El Nino. By May, you could see the warming is stronger over the Indian Ocean, especially North Indian Ocean, and then weak negative SST anomalies are shown in the eastern part of the equatorial Pacific. And then they are almost stable. So it is not going like rapidly going to higher values, indicating that it is kind of normal situation over the eastern Pacific. And then associated with that, if you see the circulation, especially in from May onwards, you do see there is strong easterlies penetrating to towards Indian monsoon region. So with a kind of anticyclonic circulation over that region. So this is from Western North Pacific anticyclone and then extending to Indian summer monsoon region, and which is also seen since this data is not smooth and very raw data, you may not see a signal very clear, but you can see that there are easterlies coming from Western North Pacific. And in July, situation is slightly different. Anticyclone is moved slightly towards the northeast, and then there is a large, strong southwesterlies penetrated towards the southern peninsular India. And in August, these August anomalies are calculated for 18 days. And it is clearly showing that there is strong easterlies again penetrating to the Indian summer monsoon region. So related rainfall anomalies, you look at from important from June onwards, you could see that associated with anticyclonic circulation, you have suppressed rainfall activities over this region extending to the Indo-Gangetic plain. So there was a question talking about why there is a deficient rainfall over Indo-Gangetic plain. It is because the anticyclonic circulation or PJ pattern, it is extending towards the Indian summer monsoon region as a suppressed Rossby wave or cold Rossby wave, and that causes a moisture divergence over this region and causing low rainfall there. On the other hand, we would see the high rainfall in the southern parts of India because the easterlies penetrating to here and creates a cyclonic shear over that region and causing the high rainfall over that region. And in July, as I mentioned, the our low-level jet was very strong. That pushed the anticyclone, and you can see the rainfall, suppressed rainfall is moved slightly northward, and that ridge is again extending to Indian region and causing low rainfall over the eastern parts of Indo-Gangetic plain. So this is the same picture, but not only the El Nino, there are other parts that are having enormously high temperature, especially in the central part of Pacific and North Atlantic, etc. So that anomalies might be having some certain impact. But what we going to discuss is more onto the related to Indo-Western Pacific anomalies. So this I can skip. Next one. So here is important plot. You can see that Nino 3.4, that means El Nino signals over Nino 3.4 are decaying by August, and August you could see some negative anomalies. So, and in Eastern Pacific already negative anomalies are set, but in the Central Pacific just in August negative anomalies are began to appear. And next, if you go to the next figure, you can see that all El Ninos are not decaying in the same month. So you can see a lot of standard deviation is high during the decay phase of El Nino. That means El Nino can decay before monsoon, within the monsoon period, even after monsoon period. So when you see this observational plot of 3.4, the black one, you can see decay is happening around July. That means it is decaying mid of the monsoon season, what we call it as a mid-decay event. So what we are witnessing here is a mid-decay El Nino event. So in this year, if you see classification of this mid-decay and early decay and no decay, so some events generally they don't decay, they become another El Nino like 14, 15, and we have some events quickly decays before May. We call it as early decay, and some of them doesn't they decay during the monsoon period. The green one, which is similar to that of what is happening now. So what we see in the monthly distribution of rainfall anomalies in this year highly determined by this mid-decay El Nino decay pattern. So when you look at the composites of mid-decay years, what you see, La Nina is slightly weak, means kind of negative anomalies here. You do see anticyclonic circulation here and warm TIO, and associated with that negative anomalies of rainfall. You can see it is blue is negative here and red is positive. So exactly what you see, this is from June to August 24. What is happening is similar to that, only you need to switch the colors. Here red color is a deficient. So you can see deficient monsoon over this region, what you see here. So it's clearly saying that the Indo-Western Pacific capacitor effect or decaying phase of El Nino is playing an important role. Related to that, you see that anomalies for JJA, A means here from again 1 to 18 days, and the associated circulation, if you see, overall, there is a weak anticyclonic circulation extending towards the Indian summer monsoon region. This is what is the problem, causing low rainfall over the eastern parts of the Indian region. And generally, when you have a decay phase of El Nino, or you do see in the summer, you do see anticyclone associated with that large suppression of rainfall over the northwest Pacific, and then that extends to the northern parts of the India or Gangetic Plain, and southern parts gets lots of rainfall. So this is also in the decay phase of El Nino, Indo-Western Pacific capacitor is active. So due to that Indo-Western Pacific, that means there is interaction between Indian Ocean basin-wide warming and anticyclone or PJ pattern over the Pacific. So they both interact and causes this distribution of the rainfall, low and high, low and high rainfall. So when you during these summers of mid-decays or decay phase of El Nino, this anticyclone actually is not favorable for the number of TCs. So we don't expect the reminiscence of those cyclones moving to the Bay of Bengal and forming any or helping to grow the depressions. Apart from that, since you have strong easterly wind anomalies here, it creates like anticyclonic wind stress curl and your vorticity is negative. Therefore, it doesn't really promote a lot of depressions or lows. Therefore, this year also we don't see many. But on the other way, if you have cyclonic circulation and positive vorticity, you definitely will have a better chance of having more depressions that can help the monsoon. So just to show you that this even in the monthly scale, June rainfall in the mid-decay years, here blue is negative, and it is happening in this June, and again it is persisting to the July. Okay, go to next one. So let us see it with more details for June month. So we have deficit rainfall here over the Indo-Gangetic Plain region, and then you can see that the yellow colors, they are like extending from the Western North Pacific. It is basically associated with this anticyclonic circulation. Apart from that, when you look at 200 HPA winds, you do see that the jet is not completely moved northward. It is hanging or around that like Kashmir or so. So that means southward displacement of jet causes generally low rainfall. So these two factors seems to be responsible for the low rainfall in June. Okay, so for more details, if you see this is the mean, actually southwesterlies are very well set, but they are weak if you see in the anomalies. That means anomalies are almost reverse. That's coming from the Northwest Pacific. So basically the monsoon flow itself is weak, and the pressure gradient, if you see here, it is a negative and here is a positive. It is a reverse. So it should not be like this for the good monsoon. And then velocity potential also shows that there is upper level convergence and it is favorable for the lower level divergence. So that is also not very favorable for the monsoon. So it is a part of large scale circulation. It's clearly showing here. So in July, the story is slightly different. What you see, heavy rainfall over the Arabian Sea and western parts of India. That is because you see that jet is penetrating to the southern parts of India, and your pressure gradient you see is slightly, again it is very different. This is SLP OLR. So OLR is showing kind of there is a ridge from extending from the south of the Japan to the northeastern parts of India or eastern parts of India. That is causing low rainfall over that region, and jet slightly moved towards north. And then this can be clearly seen. You have strong monsoon flow, and which is again supported by the anomalies. And here is SLP anomalies showing there is a strong low over this region, and then slightly high over this region. Probably this high is causing low rainfall over northeastern parts of India as well as Indo-Gangetic Plain. But there is a kind of low SLP anomalies are seen, but relatively strong over the Indian region, and which is also reflected in geopotential height, velocity potential height, So there you can see they are diverging, that means low level converging and favorable for the monsoon. And it comes to the recent period, I think second half of July and August. So when you average that, you do see again anticyclone is penetrating towards the Indian subcontinent, unlike in July. So in July, the anticyclone was towards like northeastern parts near to the Japan, but in August, that looks like again extending towards India. So again, the related anomalies you can see in OLR, there is again a kind of a tilting pattern of high OLR, indicating that the rainfall is going to be less in the eastern parts of, it was less in the eastern parts of India, and which is highly supported by velocity potential. And this is very beautiful picture for last weeks, like 12th to 18th August. And you can see very nice Kelvin wave and Rossby wave couplet, with Kelvin wave propagating towards the Western North Pacific. And there are two Rossby wave packets that can modulate the rainfall pattern over India. You can see that there is cyclonic circulation both sides of the equator, and then this is causing high rainfall over that region. And this Kelvin wave, when it propagated towards the northwest, Western Pacific, and it triggers the anticyclonic circulation. It maintains the anticyclonic circulation. When you have Kelvin wave propagating or low SLP through the to the maritime continent and Western Pacific, it drags the easterlies and enhance the divergence over this region and enhance the anticyclonic circulation. Associated with that, you do see negative rainfall anomalies over this region, and the suppression rainfall that again propagating towards the Indian subcontinent. So this is what the interaction, what we are talking is nothing but Indo-Western Pacific capacitor effect. And this is not only operational on the monthly scale, seasonal scale, it is also on the weekly scale. You can see that this situation actually happened in 2020 July. The same the pattern is reported in the schematic diagram here. So the strong convection over Indian Ocean can cause kind of this Kelvin wave, and it can impact the monsoon through Western North Pacific. And this is a forecast that we have seen already. The CFS from September onwards, the La Nina is over predicted, it looks like. So that was a seasonal forecast. And this is our in-house IITM decadal prediction model. You could see that from November 23 ICs, the La Nina is predicted, and I think magnitudes are not strong, that much strong as we see that in other forecasts, but it is stronger than observations. Obviously, you can see that, and the scale is different, and therefore this model has the ability to predict La Nina from a few months or 1 year ahead. And for not only the SST anomalies or La Nina, but also the rainfall anomalies for JJA predicted from November initial conditions. You can see this forecast is from IMD, and this is from our decadal prediction system, clearly showing low rainfall over the Gangetic plain, not eastern parts of Gangetic plain. So the question was like asked whether the seasonal forecasting models are able to capture this deficit rainfall. Even decadal prediction is able to predict this spatial pattern. This is a good thing. And if you initiate your model 2 years ago, November 2022, we do see that low rainfall, but other parts are not very well captured. And this is compared with the seasonal forecast IRI as well. You can see dipole-like pattern is very nicely predicted by our DCPS model. But it is not the end of the story. The model is very good, but there are problems. You can see you have anticyclonic circulation well predicted by the model, but rainfall is not very well, because the circulation convection feedback in Western North Pacific is not very well captured by the model. we are testing in that. Hopefully, we will get better results. So this I'm going to skip anyway. Just I want to point out that the Kelvin wave, downwelling Kelvin wave started propagating towards the Eastern Pacific, like it is from Central Pacific towards upward and eastward, and this is going to kill the means whatever you have kind of weak SST warm anomalies, and you would see that strong La Nina-like condition if this anomaly is approaching to the surface, maybe in September or October. Yeah. This is the heat content propagating towards the Eastern Pacific, and associated with this velocity potential also showing kind of propagation, and it is stagnated over this period because the negative anomalies are seen over the Eastern Pacific. So things are getting changed. So in September, if like La Nina is set up, that might favor, and also the anticyclone what we have discussed in August and June, if it is moving slightly, generally what happens, this PJ is active only in June, July, August. In September, that goes off. Once the PJ is set off, then monsoon again can take over, and we may get a better rainfall. Yeah, thank you. And I would like to thank all of our colleagues. Actually, in very short notice, they gave me a lot of figures. Thank you.
Thank you, Justy. Thanks for the nice talk. So can you please go to that figure, Kelvin Rossby?
Yeah.
Yeah, the first figure.
Yeah.
So is it related to the MJO?
MJO produce this kind of figures.
Yes. Because you know separately. So
yeah.
So any other questions?
Mid PK case, how many cases you have considered for making the composite?
Probably 6, 7.
6, 7.
Because we took long-term data, like probably 1900 to recent. 6, 7, yeah. Because you don't have like too many cases, because there are many elements and decaying in.
That's what that is why I asked.
But still, it's working.
Okay. And another one, like GPCP data you showed, no, there in June it is showing large, like excess rainfall over India, or what I saw, color bar is other way around.
Okay, color bar is probably other. We'll check it.
No, GPCP.
Yeah, I know. Yeah.
Here, June is positive.
June, but it is not in the, like, only southern parts. Southern.
About India, it is.
No, not
here.
But in the IMD data, it is not in that.
Yeah, there may be changes, but you see, the point is here, like the eastern parts of Gangetic Plain and southern parts. There is a dipole.
No, that is okay. But how the mainland India rainfall can be opposite? Means either GPCP is wrong or IMD is wrong.
Just that is wrong.
Yes. Some changes, but still it is not that much.
But this is real-time data now. Sometimes IMD may have a lot of.
So IMD, this one. What is wrong? Here is also high rainfall.
Not June.
Sorry.
This is not June.
June, sorry.
No, I saw it is June is.
Okay, let me check. Yeah. This is again.
2024 is there, no?
Yes. It is.
June was there.
It is there. Yes. June. So here it is high only.
They're asking the entire region.
Entire region is negative.
Negative, right?
This entire region is negative. GPCP is more smoother and low resolution. Like
and then also it cannot be something.
Yeah, we can check it. But broadly, if you see, this dipole pattern is there. But only thing, this is very concentrated to small region GPCP.
GPCP it is not there in the land also. It is mostly over oceans.
Okay. Check it, cross check it. Yes.
Okay. So can we?
Any other questions?
So just this
whatever you proposed is all stationary response. Are they not propagating?
Yes, they are propagating. Is there?
But he's supposed to explain June with the sender this pattern. So are they stationary or propagating? Because if it's propagating, how do you explain entire June with that?
Actually, the pattern what we say is PJ is a stationary Rossby.
PJ is stationary, but the other part you explain where peninsular, central versus Indo-Gangetic. That tripolar pattern you were explaining with some Rossby response emanating from the heating zone, right?
Emanating from?
The heating zone.
Here. Yeah.
Yeah. So will that propagate or be a stationary damped response?
No. There are two ways. Like these patterns can stay longer. Okay. For 2 months, sometimes 3 months, sometimes 1 month. When there is MJO is very active.
Yeah, but
this is not going to be stationary.
Persistence. I mean, something background has to push it against the.
Actually, when
there has to be something
yes,
to that.
yes. When El Nino is gone, tropical Indian Ocean keeps its warming, like it's a keep on warming, and that's persistent warming, causing convection there. So any part of this Indian Ocean is like if you have a deep convection, it is going to produce your Kelvin wave, and it is going
to. So that will struggle against this Rossby, and then it's becoming a stationary response.
Yes, stationary response if you don't have a strong MGO or intra-seasonal oscillation.
The absence of MGO.
Yeah, because sometimes these easterlies can suppress the active phase of IIS source also. So background is working on it. So
a stationary response even possible. Even the basic Gill model is a stationary response. You don't have a propagating component. All the frictional component damps it and stuck one place, and then it's very good. Thank you.
Thank you.
So have you seen how MJO was there in this?
Not exactly.
Okay. Actually,
India has shown it, no?
Others must have seen.
Someone has shown it. It is within the.
Yeah, it was weak inside only, but actually, Dr. Janamani is there. I think he is not there. He left. Okay. Because he was showing that figure where MJO was very weak, but he was telling that MJO had some effect. So.
But that when afterwards also it is very weak.
Yeah, because for a short period only it became active last week. So that we were seeing, like even in forecast also it was showing it was becoming active. And then again it has gone inside. Anyway, so thank you all speakers. So let us thank everyone for giving a nice talk.
Meet again after.
Yeah. So after monsoon is over or next month, sir? Before monsoon is over. Okay. So let us meet after 1 month on a comprehensive analysis of monsoon 2024. So thank you all. So
thank you.
Thanks to the moderator.
Roti.
Yeah, you can leave. Thanks a lot.
You can send them.
Swiggy करना पड़ेगा.
Thank you. Thank you.
Chalo, bye. Thanks.
Bye.
Thank you. Bye.
Problem.